And we're recording. Our production team, me and you, has said it's time to start. So, hi, Virge.
Hi, Mark. Hi, everybody. Thanks for joining us for our first episode of Another Practice Schoolroom.
That's right. And get our slides going. So, this is, as Virge said, another practice schoolroom. Hopefully, you found us. There is a QR code there, Virge. What's that going to do?
That's going to take you to the problems that we're going to work today. So go ahead and get those problems. Try and work them on your own first, would be a great idea. And then join us as we go over them and talk about them and talk about other stuff too.
And I am Mark Corelli. I'm coming at you from Denton, Texas. And this is
Virge
Virge
Cornelius.
Cornelius.
Yep. Oxford, Mississippi.
And also, if that QR code doesn't work, there will be a link in the description below the video. And
So we've been asked, do you have a plan? And of course, we have a plan. So here's our plan of what we want to do for you. This is our official first episode, and we're going to work the multiple choice, no calculator, 4 through 10, plus the BC Lagniappe. Now, Lagniappe is a little something extra, and this goes out to all of our students and teachers in South Louisiana that use that piece of vocabulary all the time. So we're going to try and incorporate a BC Lagniappe in all of our videos. Yeah, so you can look at all the rest of our plan. We're going to try and drop a video every week. That's our goal. We'll see how that works.
well said. And there's a small correction from the pilot video because we've blurred out. We put a caption in there, but plenty of people have let us know. We threw that pilot together. Oh, well, the way you would expect. And we had a typo in there. So just key information, reminder of how the exam is set up for May, 11th this year, we decided. But hopefully this video lives on future years. So go check that calendar. But 30 questions for 60 minutes with no calculator. Those are the type of problems we're doing today. And then 15 questions with a calculator for an average of 3 minutes each for 45 minutes. You're allowed scratch paper, your name's on that. And if you need more scratch paper, ask for more scratch paper. But use your pencil. Don't try to do it all in your head.
That's right. And everything's delivered digitally now, including the free response. But your free response answers are going to be written in a booklet, and then the booklet gets sent in to College Board where they scan it, and people who are calculus teachers grade your free response questions. So 2 questions, 30 minutes, graphing calculator allowed, both the embedded one and the handheld, and then 4 questions, 60 minutes, where no calculators allowed.
Awesome. And scratch paper again, but again, that is not collected. So put anything you want to communicate in your answer book.
All
All
right,
right, Virge,
so
are you ready to share?
I'm gonna go ahead and share. You're gonna want to not share. Okay.
I did.
Okay, so I'm sharing my overhead, my document camera right now. And these are ones that if you want to know the answers and how to work 1 through 3, those are in a pilot. So go to that pilot episode that we did for you. And I'm going to work 4, 5, 6, and 7, 6, 7. Ha ha ha. Maybe I'll do that every video. It is so cringy now that the adults are doing it, right, everyone? All right, so I'm going to work 4 through 7, and Mark's going to work whatever the rest of them are, right, Mark? Okay. So this one says evaluate the limit as x approaches infinity of some factored polynomial over some other factored polynomial. And if I go ahead and I expand this, I will have a trinomial over a trinomial. I think I know pretty much that if I expand this, I'm going to have a situation of infinity over infinity, or in particular, negative infinity over infinity. So L'Hopital's rule is going to apply. And I'm just going to write that, L'Hopital's rule applies. There's multiple choice. No one really cares what you write down. But in order to save a little bit of time, I'm not going to multiply it all out. I'm just going to think about what multiplication gives me the leading term essentially with this polynomial. So it's negative 2x times x, so it's negative 2x squared plus a whole bunch of other terms. Well, 3 once you combine. And then in the denominator, it would be x times x, or x squared, plus again, a whole bunch of terms. And since L'Hopital's rule applies, you're going to go ahead and take the derivative of the numerator, the derivative of the denominator, and try again. So let's see. I'm going to get negative 2x plus, I guess, some terms all over. Ooh, that would be,
4x.
thank
That's going to be
you.
a 4. Yeah.
Yeah, you know what? I already had the 2x in the denominator going in my
I
head.
really, I really thought for a second you were going to go product rule.
What do you mean?
You were doing negative 2x times x, and you were doing a product rule. I was like,
Okay.
wow, what an obscure way to do this problem.
Yeah. Yeah. Plus, some linear term there. And then L'Hopital's rule will still apply. And so I'm going to do the limit as x approaches infinity of, it ends up being the derivative of negative 4x is negative 4, derivative of 2x is 2. Final answer here is negative 2.
And of course, this is a rational expression. It is two polynomials, as Virge said, and you could use end behavior rules and right off the bat jump to the negative 2x squared over x squared, simplify that to negative 2. And one of the great things about the power of that limit notation, and this is actually, I don't do it with L'Hopital's rule, but I usually write the plus dot 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 just as a reminder to my students. But the power of the limit notation is if Virge wrote equals limit as x goes to infinity of negative 2x squared over x squared, that is true. It
Mm-hmm.
is equal to the limit of that ratio of the lead terms. And so,
Mm-hmm.
real slick way to do it.
I'm so glad that you brought that up about the rational, the ratio here. I mean, essentially, this is what kind of asymptote that we're really being asked about.
Yeah, you find the horizontal asymptote of a rational
Exactly.
function. Yeah.
Exactly. So that's exactly right. Okay. If at any point this seems confusing to you as you're watching this, pause the video, talk about it with your friends or your teachers or whatever. Maybe go ahead and make sure to multiply this out for yourself. I'm just trying to show you how I would think about it. That's all. There's lots of different ways to think about it. So that's number 4. Okay, number 5. Let g be the function defined by g of x equals 3x plus 3 natural log of x. What is the value of c for which the instantaneous rate of change of g at x equals c? Gosh, that sounds like a derivative, instantaneous rate of change, is equal to the average rate of change of g over the interval from 1 to 3 inclusive. All right, average rate of change is just going to be g of 3 minus g of 1 all over 3 minus 1.
Sounds like you're setting a derivative equal to a slope.
Which sounds like kind of mean value theorem, right? But we don't even have to know that to do a good
Right.
job on
They're
this
just asking
problem.
us if this happens. Yeah.
Yeah. Okay, so I need to take the derivative of g. So that's going to be g prime equals derivative of 3x is 3, just a linear term, plus derivative of 3 natural log of x is going to be 3 times 1 over x, or 3 over x. It's probably how I would write it. And then here, I did this problem earlier this morning, so let's see if I can do it correctly this time. G of 3 is going to be 3 times 3 plus 3 natural log of 3, or 9 plus 3 natural log of 3. G of 1 is going to be 3 times 1 plus 3 times natural log of 1. Natural log of 1 is 0. You remember that from pre-calculus. So this whole term is gone, goes to 0. So that's 3. So let's see. G of 3 is 9 plus 3 natural log of 3 minus G of 1 is 3. And then all divided by my 3 minus 1, my b minus a in the denominator. So it's looking like 6 plus 3 natural log of 3 all over 2. How's that looking on your end, Mark?
Really good.
Okay, good.
Much
So,
better than the 8 I got this morning.
wait, you messed up this problem this morning too?
I mean, I was doing it in my head, which is why I stressed scratch paper. But yes, I did 3 times 3 was 1.
Well, I was doing it in the car, but I was not deriving and deriving.
Yeah.
Oh no, that's
Yeah.
so bad. Anyway,
Yes.
okay.
I was doing it because somebody texted me from the car saying, "What's the answer?"
Why am I doing wrong here? Okay. Okay, I'm going to multiply my entire equation here by 2 to clear that denominator. So I get 6 plus, distributing here, 6 over x equals 6 plus, these 2's cancel out, 3 natural log of 3.
Yay.
Yay, it's looking correct. So subtract 6 from both sides. Get 6 divided by x equals 3, natural log of 3. Multiply both sides by x, lots of algebra going on here. And then, no, 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 no. Something went wrong here.
Oh, you're good.
I'm
You
good.
are good.
Okay, I'm good. All right, so multiply both sides by x, and then divide both sides by 3, natural log of 3. Okay, I was like, where's the 2? I know there's a 2 at the end here. It's right here. 6 divided by 3 ends up being 2. So my answer is 2 over natural log of 3. Okay.
That's a very involved multiple choice problem, but realize that that timing of 2 minutes per problem doesn't mean you should have a 2 minute timer in your head. There's going to be questions that are really quick, and then there's going to be questions that maybe you spend 2 or 3 minutes on, which is a lot of time, really.
Yeah, to me, this question should be a quick one, you know,
Right.
because I wouldn't spend the time multiplying out those polynomials. But anyway,
Exactly.
okay, let's see about number 6. This one's quick if you know what to do, so it's a great thing that you're here watching this because if you've never seen something like this before, it won't be quick for you. You'll be stressed out about it. But since you're here, we're going to make it hopefully a little bit more palatable for you. So we've got a graph, and it says the graph of g of x is shown, and we want to know the limit as x approaches 1 from the left of a new function, g of x plus 1. So g of x plus 1, what's going on there, Mark?
Well, I would just focus on that argument, right? Like, what's x plus 1 doing as x approaches 1 from the right, or from the left, sorry. And
Mm-hmm.
so it's approaching 1 plus 1.
Mm-hmm.
So it's going to approach 2 from the left. It's going to be like 1.9 and 1.99 and 1.999. So,
Okay. So, actually, I totally don't think about it that way. I think about shifting this graph.
oh, excellent.
Uh-huh. Okay, so I'm
Yeah.
going to do it my way because you just
Yeah.
confused
I do
me.
a u sub. I do u equals x plus 1.
Okay. Okay, so I'm going to think about this is a shift to the left. And so I'm going to take my entire graph and I'm going to bump it to the left by 1. So that means that I have an open circle now at 1, 1 instead of 2, 1. And then I'm kind of bringing everything down like this. And then I've got my value of the function at 2 right there at,
Uh,
yeah, that moved over. And then
you could
this,
even change the scales, right? Like just change the scales to 0, 1, and 2 or whatever if you
oh,
need.
cross these little guys out. Yeah.
Yeah.
Well, so now I'm looking at my purple graph because that's the graph of g of x plus 1. And as x approaches 1 from the left, so I'm approaching 1 here from the left-hand side, what's happening to the value of my function? Well, it's getting to be 1.
That's funny because the way the face you were making when I started talking about approaching 2 from the left was was like, what are you
Bad
talking about?
face.
But if you
Bad
look at
face.
the graph, if you look at the black graph, the one that was pre-printed, the hand drawn one, right? As
Uh-huh.
you approach 2 from the left, you are approaching 1. So
True, true. Okay. Very nice. Either way is good then. What would it be where we would have an answer of does not exist? Just curious.
it would actually be really hard with a one-sided, wouldn't it? It would have to almost be asymptotic because so many of our limits exist from one side. If it's a jump discontinuity or a removable, that one side it's going to exist. So it's really going to have to be
But what about
something really
this?
nuts. Now that's a problem.
Yeah.
If we're approaching both sides have to match up, right?
Yeah,
And
and
both
then
sides do not match up here.
yeah, on the original G of X. Yeah, this one would be does not exist. So, Mark and I have been doing this for a long time, not just talking to each other, but also calculus. And so I always think about like what are other kinds of questions that could be asked off of the same graph because this one's an easier question, honestly, and you're going to get some easier questions on your exam for sure. All right, what did we say I was doing, Mark? I'm also doing number
We're
7.
going to do 7 because I'm
Okay.
going to do 8, 9, and 10 in the Lagniappe,
Okay.
a word I learned this month.
Yes, Lagniappe, exactly. Okay, I got to cut number 7 off because that's the way I do these things. Okay, so here's number 7. Particle P moves along the x-axis with velocity modeled by v of t equals 3t squared plus 6t for t greater than or equal to 0. Particle P has a position function x of t and has an acceleration modeled by a of t. At time t equals 2, x of 2 equals 1. That sounds like an initial condition to me. And then we're supposed to find x of 0 plus a of 1. could do this in any order you want. I would probably maybe think about a of 1 first because I'm just going to take the derivative of velocity and figure out my acceleration. So v prime of t always equals acceleration, a of t. So these are power rule. So 2 times 3 is 6. So I have 6t plus derivative of 6t is 6. Now I'm going to substitute in 1, right? So I'm going to get a of 1 is 12. So I'm going to keep that on the back burner because it's a little bit more going on to try and figure out x of t.
Hold on.
Right. So
Neat
x of,
problem.
say it again, Mark.
It's a neat problem, which
Yeah.
is the something calculus students do not want to hear calculus teachers say.
Yeah, well, I wrote it, so I'm sure my own son watching is probably going to definitely not want to hear that. By the way, Mark and I both have our own children in our calculus classes this year, and they're taking the exam with the rest of you. So, anyway, all right. X of t, I have to go backwards because the position function is the antiderivative of the velocity function. But this is pretty friendly. You can think about whose derivative is 3t squared. It's got to be t cubed. Whose derivative is 6t? It's got to be 3t squared. And then plus some unknown constant of integration. We're going to find that c value by substituting 2 in for t and then setting the whole thing equal to 1. Sorry, negative 1. Okay. So negative 1 equals 8 plus 3 times 4 plus c. It's looking like, if I did this correctly, c is negative 21. Okay, so x of 0 would be,
For
say it again.
so was that for?
Well, I was just kind of like, there's a negative 21 there. I don't want to be like
Yeah.
fooled by that, right?
There's a 12 there too.
Yeah. Oh, shoot, there sure is, isn't there? Okay. So x of 0 would be, 0 cubed plus 3 times 0 squared minus 21. So x of 0, the initial position is negative 21. So I got to add that to the a of 1. So negative 21 plus 12, I believe I'm getting negative 9.
I believe you're right.
Mm-hmm.
And again, it's like we almost should do two videos. We should do a video where like Virge's take and Mark's take because
Maybe we
I would
should
have
plan that for later.
x of t. I would have done that value x of 2 plus the integral from 2 to 1
Oh.
or from
Mm-hmm.
2 to 0, sorry, from 2 to 0 of 3t squared plus 6t
Mm-hmm.
and gone straight to the negative 21 that way. Of course, it uses all the same information. It's
Mm-hmm.
almost the exact same number of steps, but doing
Mm-hmm.
it as an accumulation model.
Mm-hmm. Love that. Love that. That's exactly where we are in calculus right now, actually. So imagine that. Okay, I think it's your turn, Mark.
It is.
Okay, so I'm going to stop my share. Um, I don't even know where this is going.
I think I might be able to take it from you.
Okay, good, because when I'm on my overhead, it's always a pain in the neck for me to try and,
You're still sharing, but
yeah.
I have started sharing, so
Well, maybe this is our issue with, hold on a second. Maybe this is our issue with that other thing though. Um, okay. All right. Okay, here you are.
okay.
Ooh, look how fancy you are. No over document camera for you.
Except that I can't see it right now, which is really funny.
Well, how are you going to
'Cause-
write on it
well,
if
no,
you can't see it?
we might have to edit this part out. Now, when you unshared, you showed up in front of it. I was,
Oh, okay.
I was like, I can't see it. No, I can see
Okay.
it on my tablet. All right. So number 8, another limit, and
Mm-hmm.
this one is not a rational function. That numerator is not a polynomial. So I'm going to go ahead and jump over here and look at my limit as t approaches 0 of my numerator. And again, like Virge said, you don't have to do multiple choice. No one's looking at your work. So this work could be a little less formal. Looks like sine of 0 and e of 0 is 1. So I get 1 plus 0 minus 1. You do have to know your unit's circle. Sorry about that. At least the first quadrant.
Not sorry. You're not sorry.
I'm not
He's
sorry at
not
all. Okay.
sorry. You have to,
All
your unit
right.
circle.
So smiley face optional, but we get 0 for the denominator as well with 0 minus 0. I skipped the step of 0 squared minus 3 times 0. I feel like we're all grown up enough maths here that we can skip that. But I do get a 0 over 0 situation. So we're going to use L'Hopital's rule. So again, I would never write that on multiple choice. Don't take the time. But for you guys, I'm going to take the time. And so this is going to equal the limit as t goes to 0. My derivative of e to the 3, love exponentials, e to the 3t, sorry. It is e to the 3t. But Vert, is that exponent just a t?
No, it is not.
So chain rule, we get a
Hmm.
3 out front. And then my derivative of sine, do you remember the derivative of sine?
Cosine of t,
Yay, and the derivative of negative 1.
gone.
So I can stop my ratio there. And now the derivative of the denominator. With L'Hopital's rule, we just do derivative of the numerator and derivative of the denominator. They don't interact. So we're going to get 2t minus 3 in the denominator.
Hmm.
And now we see if this works. And I'm going to go more direct this time. We're going to go, if I evaluate this at 0,
Because he's only worked this problem like 4 times already, so he knows this is the end of
right.
L'Hopital's
Well, and
rule.
also, even if I wrote something that was a 0 over 0 and I didn't want it equal to, it's multiple choice. And I know that I can just apply L'Hopital's rule. On a free response question, you want to try not to write equals to something that's not true or not evaluatable. That's a word. Um,
It's a word now.
it is now. All right. Um, let's see. In the numerator operator there, just speaking of made up words, e to the 0 is 1 still. So we get 3 times 1. And then cosine of 0 is also 1.
Mm-hmm.
And 0 minus 3 looks like we're getting negative 4/3 or choice A.
Yay. Good. That's what I
All
got.
right. Okay. All right. Number 9.
Mm-hmm.
Um,
Love this question.
yeah, number 9. Yeah, you wrote it, didn't you?
Yeah, but I never remember that I write stuff,
Okay.
but I do
Sorry.
love this question because
Okay. I'm going to
it's
scroll up. I thought about not scrolling up and then I realized it's video. You can pause and rewind. Um, all right. So this looks like it's very first quadrant heavy because the square root of x is only living in the first quadrant. And it didn't say to sketch it. Some of you might be able to do it without sketching. What just happened? Oh my goodness. Oh, I just scrolled to the top of the page. Thanks, UI. Okay. Um, Square root of x. Let's see. Oh, should we figure out where these are equal, Virge, or should I just graph it? What do
well,
you think?
both. The thing is that like it's non-calculator multiple choice, so they're going to be equal to each other at like 1
Right.
or 4 or
Right.
9, some like nice square root.
I've got these nice points, right? Let's
Mm-hmm.
see. These are some good candidates. When I plug 0 in here, I get 4.
Yep.
Um, that 0 over there was a little misshapen, but and then when I plug in 1, well, I don't like 1, but if I plug in 2, I'm going to get 2. Negative 4. Let's see. This is the magical one, right?
Mm-hmm. At
Yeah,
4, you
so
get
there's
2.
our,
That's the intersection of the
no,
line and the square root
that's,
function. Yeah.
yeah. So, um, and then, so I know I'm going to take my square root out to 4, 2 on my parabola. And then this line starting there has a slope of negative 1/2.
Mm-hmm.
So we're going to take this out a little bit.
Now you are going to have to figure out where the line intersects the
Right.
x-axis.
So
But
where's
luckily you
this
had
going to,
algebra 1.
yay. Yeah, so we're going to set that negative half x plus 4 equal to 0. And it looks like x is 8.
Mm-hmm.
And I will admit, the first time I did this, I was like, man, Virge made me do 2 integrals in one problem. That's crazy. And then the second time I did, I was like, oh, wait, that's a triangle.
Mm-hmm.
So I am going to do that part of the integral or the area bounded by these things by using the fact that that is a triangle of height 2 and width 4. and everything's positive. So that's 4.
That's what I got. And I
And
also did it
then
that way.
my other part, if I integrate from 0 to 4, and I rewrite that square root as x to the 1/2,
Hmm.
because I like power rule. And I just, for power rule with fractions, I just add the denominator to the numerator. So 2 plus 1 is 3, since I'm adding 2 halves. Throw that reciprocal out front because I'm going to divide by 3 halves. And then my bounds go from 0 to 4. You are making me do a lot of algebra 1 and algebra 2 in this problem. I like it.
Yeah. And I think that's fair. You know,
Oh,
you're
yeah.
not going to have to do it on every question, but you're going to need to leverage those prior skills for sure.
Okay, so I've got this rational exponent of 3 halves, which is a power over a root. The 0, I feel pretty confident. That's going to be 0. But the square root of 4 is 2. And then 2 cubed is 8. So I'm going to get 2/3 of 8, or 16 thirds. And then for my final answer, I'm going to take 16 thirds through that area, 4.
Hmm.
And 4 is going to be 15, 12 thirds. I almost multiplied it by 4. That would have been tragic. All right, and we get
Great job.
28 thirds.
Can I say
Well,
one other thing about that problem?
absolutely, Virge. You can
A,
talk all
a
you
lot
want.
of times when you see two different functions in an area problem, students might think that they have to subtract, do like top minus bottom or whatever right off the bat. And
I
that's
try to
just,
play with this area. Yeah.
yeah, and that's just not what's happening here. So anyway, you'll probably do those kind of practice problems too as you're getting ready for your exam.
Well, we
Okay,
might even throw one at you in the free response practice.
sure. Because we haven't written everything yet, right?
And I would like to say, like, this is like, again, going back to the idea, like, this one is an involved problem, but not they're not all involved. We are not doing the ones that are like find the derivative of 3x squared plus 8. And so you will have time. Running out of time, I don't think is big of an issue as it could be. I certainly don't want you worrying about it. All right, number 10, kind of staying in our unit 8 material, of area volume. It says the region R is the area bounded by the graphs of y equals x squared and y equals x cubed. Which of the following definite intervals can be used to determine the volume of the solid generated when region R is revolved about the x-axis? So we don't have to find the actual volume this time. That's nice. And as far as finding the bounds goes, they've actually thrown us a little bit of a hand here. These are all
Yeah,
bounded from 0 to 1.
yeah.
I still draw them every time. As those of you who've watched anything that I do know, I'm keep the pencil moving, and I want to know what this thing looks like. But I do know that x cubed and y cubed are both 1, 1, and they both go through 0, 0, right? And
Hmm.
I've got a parabola, and then I've got something kind of doing an S curve. We have very small shape. And then we're revolving that about the x-axis, correct?
Yes.
So, and Virge knows you can't use a lot of different colors on the test, but you can have a black pen and a blue pen. So
And a pencil.
that's right. See, the mirror of this thing is going to be like S curve coming that way, and the parabola coming that way. Whee! And so we're doing that volume. Kind of cool. I'm going to go back to the blue because I like the blue. All right. And so I'm looking for, got like one disc in here, right? Because there's a hole and there's an outer part. And my drawing is not great, and I'm actually awesome with that. You don't have to draw well, you have to draw well enough.
And also well enough that you understand exactly what you're supposed to be doing, right?
No, hopefully
So,
well enough that you watching on this video understand as well. But yeah, if I tried to draw this, I'm going to take advantage of my technology here a little bit. But I'm trying to find that big R and that big R because every one of these discs is we're trying to find that shaded area. So which graph's on top? You tell, Virge?
well, I could tell because of how you drew it that the x squared, as these graphs travel from x equals 0 to x equals 1, is actually always above y cubed. But the way I never remember that myself, so I always plug in a half. And
I
oh
was
my
trying to
gosh,
just,
is that what you were doing? Okay, so
I know, I knew where you were going. I was like,
okay,
she's
so
got to be doing this.
because it it's multiple choice, and we might not have the other option, which I was glancing at the options. I was like, yeah, we didn't have the other option, but we need to know which one's on top for that outer radius. So the quadratic's on top for the outer radius.
And so, and then of course, the other reason I drew this washer here, and I wouldn't necessarily draw the washer when I'm doing this problem, is that that's pi r squared minus pi r squared. It's the big circle minus the little circle,
Hmm.
and they have a pi in common. So I'm looking for that form. So C and A are gone. So I want the pi, and I want this squared minus squared form, right? And here on this one, I only have that square in that one spot. B's looking really good.
Hmm.
There's that's my r squared or my x squared squared. And that's my little r squared or my x cubed squared.
Yeah, and I might add here that B is a really good answer for a slightly different question.
Yes,
What
absolutely.
is the question, Mark?
Square bases.
Yeah, like that little sliver of area is the base of a solid. Cross sections perpendicular to the x-axis are squares, and then that would be your answer.
Yeah, they'd be these little guys, which I'm not going to try and draw it any better than
Yes, because it is such a
that.
tiny region. Yep.
All right.
The
And
lanyap.
for our BC students, our lanyap, our additional, our little extra.
Bye bye
And
to the AB students who are
to,
probably saying
uh,
bye bye.
that's we're like 20 minutes in. They left a while ago. Uh, uh, or they're on double speed and they'll just go with it. Um, we uh we just did this with my BC students this past week and they really like it. So this is the power series given as n goes from 0 to infinity of some unknown rule a sub n times x plus 1 to the nth power converges at x equals 4 and diverges at x equals negative 8. And which of the following statements about the convergence of the series must be false? And um, I always think of Virge during these because the two words converge and diverge. Like, oh, that
Yeah,
must have
I
been very
know.
distracting for you when you were in that class. And wow, I know we didn't write these problems deciding who was going to do them, but when we divvied them up, man, are we just going to hone in on the fact that I like to draw stuff? That like you should draw the situation,
But
and so
I solved these earlier today and I drew them too. So,
yeah. And, oh, it's yeah. I don't think I'm alone in that. I just think it's definitely being emphasized. All right. So um, that is centered at -1. And I know that from my BC students, this is a power series, and power series are all of this form where you have the nth derivative at c over n factorial and all that. But they left off that part because they didn't want to give away a whole lot. So we don't know what form this derivative takes, but we know that x minus cn, c to the n part. So we know that c is -1. And then I know that it converges at 4. So I'm going to go out here 3 points or 5 points away, right? It converges at 4. So that point is good. Of course, it converges at the center, always converges at the center. Um, and then we know it diverges at -8. So how many ways is that on the left, Virge?
let me see. My dogs were barking just now, so I put myself on mute. 7 to the left, it looks like.
Yeah. So
Okay.
I think I counted 7 out there. Honestly, I don't even mind. But I know it diverges there. So for those of you that haven't done a lot of these problems, there's a lot of good information happening. I'm going to start getting my highlighters out. Um, we know that there's an interval of convergence and there's a radius. And there's some information here to give us an idea about the radius. I know my minimum radius is 5. I know everything in here has to converge because there's no way this thing stops converging and then starts converging again. So I know it converges at 4, so it converges up to 5 that way. But what's 5 the other way? -1
Negative
minus 5.
6. Negative 6.
So got the point at -6. I know we're good up until -6. Now, you might be wondering, hey, Mark, 4 was colored in. Why didn't you color in -6? Well, we don't know there because if 4 is an endpoint, then -6 might be an endpoint. And the endpoints are the one things we have to test individually. We know it converts absolutely inside, but the outsides are the only places it can converge conditionally. And this thing might converge at 4, but not converge at -6, which means now I have to deal with my divergence. So I know it for -8, it starts to diverge. So it's going to diverge for everything outside that. And we know we're converging in here. Well, -8, we said was -7 to the left. Is that right?
Mm-hmm. Mm-hmm.
And so is that left, right? And so 7 to the right, be a
11.
+6
Oh, wait, 7 to the right of what? Oh,
of the
negative
center.
1.
Sorry, of the center.
Yeah,
Yeah.
yeah,
So
yeah.
this is potentially my radius, or this is potentially my radius. I don't
Mm-hmm.
know which one.
Okay.
It's got two potential radii. And we don't know which one's right, but I know that outside that it has to diverge. Same idea that if -8 is the endpoint, then everything that's farther than 7 away from -1 is going to diverge. And then we've got the questions. -6 up until -8, and between just past 4 up to 6 are our question marks. We just don't know. Now I'm ready to go through my choices. Does the series converge at -6? Well, I have my big question mark there, so I can't say that for sure. We're looking for must be false,
Mm-hmm.
right? Um, does it diverge at -4?
Looks like it's converging there.
-4 is converging, that would be false. Let's keep going just to make sure it's 6. We have another question mark. That's my corresponding endpoint to -8. And at 8, we know it diverges. So that is true. And so the only one that must be false is B.
Yay!
I enjoy those too much. It's
Nah. There's no such thing as enjoying math too much. All right, we've come to
hey,
the end of our first episode. So we're
episode 1 is in the books.
yeah, we're so thrilled that you guys joined us and look for our episode 2.
Hi, Virge.
Bye, Mark.